So the next few videos are going to be about the bipolar junction transistor, or the BJT. Transistor, BJT. And before we begin, I wanted to just take some time to ask, what exactly are we trying to figure out? So what do we want to know about the BJT? Well, you're probably taking this class because you're an aspiring electrical engineer and you want to be able to use a BJT. So you want to be able to plop this thing in some circuit and it's going to behave a certain way and you're going to be happy. So we want to know how the BJT is going to behave. So how this device is going to behave. And this is typically referred to as the BJT's modes of operation. And we'll cover this in future videos, but the basic idea is if I apply, say, a certain voltage here and a certain voltage here, so let's just call them V1, V2, how is the device going to behave? What are the currents in the device going to look like? So what is this current going to look like? What is this current going to look like? And this qualitatively and quantitatively is described by the BJT's modes of operation. We also want to know how not to destroy the BJT. So how not to destroy the device, because for some voltages I apply to this device, I might actually break it. So maybe if V1 is greater than, I don't know, 20 volts or something, this device might explode. And so we want to know when exactly that's going to happen. And just to be a little more realistic, this explosion voltage might be close to 1 volt. So you see how careful you have to be when using these devices. Fortunately, for most of the use cases of a BJT, there is one number, one single value that is a figure of merit. Or a number that tells us how well the BJT is going to do what we want it to do. And this is the current gain. So if you're not familiar with this, that's fine. If you are, that's great. This is what we're ultimately going to be building up to. But in device physics, we're physically more interested in this figure of merit you can get from beta called alpha. And we talked about the BJT as essentially a diode connected to a bucket. And the bucket is collecting all of the diode's current. Alpha describes how leaky is my bucket. So an alpha equal to 1 means we have perfect collection. So every hole or electron that's injected from this diode or from the emitter of the BJT is collected by the collector. And an alpha equal to 0 means we've got no collection, meaning that of all the charge carriers we inject from the emitter, none of them make it to the collector. And we can write this as an equation. IC, so the collector current, is just equal to alpha times IE. So alpha describes how much of the emitter current makes it to the collector. And ideally, if alpha were equal to 1, beta would be equal to infinity, and this device would just be absolutely amazing. We'd be able to do all sorts of fun tricks with it, and every amplifier we'd ever design would only need 1 transistor in them. Unfortunately, that's not the case, and so we want to know what exactly is alpha. So what's a typical number for alpha, and how do we get it? And to figure this out, we're going to need to figure out, okay, well, if I've got a BJT structure, say it's a PNP, we need to figure out all of the currents involved in this device's operation. So where are all these holes moving in the emitter? Where are these holes moving in the collector? What are the carrier distributions of electrons and holes look like inside this device? So if we can figure out the minority carrier distribution specifically, so P of X, for example, in the base, and N of X in the collector and emitter, for a PNP transistor, then this will give us all of the currents or current densities, and we'll be able to figure out alpha. So that's ultimately what we're going to be building up to in the next few videos, as well as covering modes of operation and how not to destroy your BJT. So I look forward to seeing you in the next videos as we learn about the BJT. If you enjoyed the video, please like and subscribe to my channel. And if you have any questions, please feel free to post them down in the comments below. Thanks.